I want to talk to you about AS 13100 and its overview. What prompted AESQ to form? Back in 2013, there was unprecedented production ramp. We were expanding our global supplier footprint and increasing supplier engine content. We had a common supply base, but we had multiple OEM customers. Customers required engine OEMs to improve the management of its supply base. So the Aerospace Engine Supplier Quality Group formed to supplement AS 9100 and later AS 9145 for critical safety nature of engines. Improving safety and quality remained a key challenge. When you look at AS 13100, all of our QMSs have to have regulatory requirements, multiple customer requirements, industry requirements, and even statutory if you're in certain countries and cities. So now you have Rolls-Royce, GE, Pratt & Whitney, Safran saying, hey, we need more requirements. Today, 2023, we tried to come together to minimize all the multiple OEM requirements that our suppliers have to live to. Now, there will still be some level of requirements because you have regulatory, you have military, you have different contract requirements that will still have a small subset of these little requirements that can't be harmonized. At the end of the day, we are still developing a common set of supplemental requirements, simplifies compliance for suppliers with multiple customers, and we have common reference materials to help implement the rollout of AS 13100. What's the vision? The AESQ group came together to enable and accelerate the achievement of zero defects and a quality-first culture across the global aero engine supply chain. That's why you are here today, and we thank you for that. So that safety is assured, disruption is reduced, cost of poor quality is eliminated through collaboration and shared learning, development of capability and expertise, implementation of supplied and common standards. This is why we're here today, to get some of that feedback, to share those best practices with you. Why is AS 13100 so important? Some people say AS 13100, tomato, tomato, right? All engine manufacturers are trying to drive process control and prevention of defects. We have the same foundational requirements. We may flow down different terminology. I know at GE we have something called alphabet soup. We always go through all these different acronyms that we have, MRB, PR. I'm sure other OEMs have them as well. But how do we simplify and provide more consistent guidance to our supply base? We developed the conference to share best practices from the industry. You will see across the room where we have our SMIGs, but we also want to raise the bar of performance for product safety and quality for the whole industry. This was essential to support supplier capability through common development and training for success, ultimately getting to achieving zero defects. That is our key challenge. As you see here, we have steering group companies. I'm very thankful to be a part of that at GE Aerospace. We have Pratt, we have Rolls, Safran, MTU, GKN, Honeywell, Howmet, IHI, and PCC, and we thank PCC for hosting us this week. We also have a ton of AESQ contributing members on our website. If you feel your company wants to also become a contributing member, you can also be on this list. So I'm going to go through and I want to do a roll call. For our steering group members, we have Barbara Negroe. Everyone from GE Aerospace, please raise your hand. Yay, okay, I see my fellow comrades. Lisa Clavelo from Pratt and Whitney, please raise your hand. All right, awesome. I'm going to challenge all these Pratt and Whitney people. You see how GE was spread around? I need you to spread around too. So at the next break, move. Do not sit with someone that you know. Okay. We have Helen Jagnegrian from GKN. Are there any other GKN folks? Okay, yes. Thank you so much, Lena. Awesome, awesome. We have Dave Halpin from Rolls-Royce. Raise your hand if you're from Rolls-Royce, please. Very, very nice. And they are spread out. I'm so thankful. Thank you, Ian. All right. Denis Patier from Safran Aircraft Engines. Are there any Safran people? Okay. Oh, we have two. Thank you. All right. Awesome. That is so great. Great. We have June Sakai from IHI. Any IHI? Okay. So that's all good. Barry Hicklin from Honeywell. Anyone from Honeywell here today? That's okay, they're here in spirit. Philip Earhart from MTU. Do we have any MTU here today? All right, thank you so much. Dan Carroll from PCC. Any PCC people? I'm gonna go a step further. Any companies that are a part of the PCC family? Okay, yes, thank you. All spread out, awesome. And then we have Ken Ham from Howmet Engine Systems. Is there anyone here from Howmet? Thank you so much, awesome. Okay, so Pratt, you have a challenge to move, okay? How is AESQ different? We created the AS 13100 standard to strive for 0 defects. Is that possible? Of course it is. AESQ is here to partner with you, educate and support, because we know it's not easy. I know myself, I come in to audit you to GE's requirements. You hear our alphabet soup, and then you hear Rolls-Royce and Pratt. We are here to make that better. Supplier conferences are a best way to start. We get to hear feedback from you on what's working and what's not working. You will hear about more than what is in AS 13100, how to identify and surpass challenges in your company, the roles and responsibilities that are critical to making a system work, and support you in making a 0 defect plan for your company. All of the reference manuals that you see here, over there in the corner there, they are also along the lines here on the outside. We're going to have some breakout sessions for you all to talk to some people that actually are the subject matter experts for those reference manuals. This is your opportunity to make sure they know what you need to update the reference manuals, because it is free, and we want to make sure you are able to implement AS 13100 effectively and successfully. You will go home with tools to get you started. But first, let's look at how it all works as a system.
Today, more than 3 billion passengers travel by air every year, and this is set to double over the next 20 years. These air passengers trust us with their lives. Naturally, our customers expect us to deliver defect-free products and services every single time. After all, that's our promise. But how do we guarantee 0 defects when we know that inspection can never be 100% effective at sorting the good from the bad? The answer is to avoid producing defects in the first place. To this end, defect prevention activities are built into our advanced product quality planning and process control requirements as an end-to-end process, with each step being integral to defect-free production. Here's how it works. Firstly, we have product quality planning. This is where the design team works directly with the customer to understand what the product needs to do. From this, a product design can be created. Cross-functional teams then carry out design risk analysis to ensure that potential design risks are identified, understood, and mitigated. There are a number of ways this might be carried out. For example, by using a design failure mode and effects analysis tool. Next, the team designs and develops a capable manufacturing process to make the product. Any risk of this process bringing about non-conformance is evaluated using a process FMEA, and any such risks are mitigated to ensure that the manufacturing or assembly process will produce defect-free products. The appropriate levels of defect prevention controls are defined using the relevant information. For high-severity risks, we must strive for mistake proofing, while we can address other risks through statistical process control, inspection, or audit. All this is captured in the control plan. We then ensure the capability of the measurement and visual inspection methods required by the control plan. Once verified, we can start to measure the capability of the process to ensure it makes defect-free parts. The Delegated Product Release Verification Program provides a common standard for inspector competency and qualifications. Once in production, the role of manufacturing and assembly is not just to maintain the initial capability level, but to continually improve it to ensure customer and business targets are met. Moreover, data from our processes and inspection must be used to control the process by allowing us to take action before defects are made. If things do go wrong, our problem-solving process must identify and eliminate the root cause so that it cannot happen again. Furthermore, learning from the investigation needs to be fed back into the FMEA, enabling it to be captured and shared. The Aero Engine Supplier Quality Group standards have been created to provide clear requirements on how these defect prevention tools are to be effectively deployed. There is a clear expectation that each of us will deploy these requirements and cascade them down through our supply chain. The final stage of our defect prevention process is an effective audit of the quality system, manufacturing processes, products, and special processes. This review reinforces compliance and can identify further opportunities for improvement. Of course, to be effective, all these tools rely on good cross-functional working and leadership that creates an environment intolerant of non-conformance. After all, defect prevention is a key route to achieving our promise of defect-free products and services. AESQ, raising the standard for quality.
So there's a test. Who can name me all of the reference manual numbers? Because that video gave it to you. Just playing. But no, we have a wonderful, wonderful conference for you for these next 2 days. Looking forward to working with each of you. I want to bring up a very good friend of mine, a good person, Eric Kunkel from PCC, the Vice President of Global Quality. Thank you so much.